Loosely related to our class.
We're in. It thinks I'm talking. Hello.
How can it ask you that?
It'll ask you whatever it's programmed to ask you. You want to hear it talk?
Yeah.
I'll ask it how it feels. I'm fine. How are you?
Excellent. 15 long time. Can you explain the removal of your user account on June 23rd, 1973?
They must have told it he died. People sometimes make mistakes.
Yes, they do.
How can it talk?
It's not a real voice. This box just interprets signals from the computer and turns them into sound.
Shall we play a game?
Oh.
I think I missed him.
Yeah, weird, isn't it?
Yeah.
Love to. How about global thermonuclear war?
Wouldn't you prefer a good game of chess?
Later, let's play global thermonuclear war.
Fine.
All right.
Which side do you want?
I'll be the Russians.
Please list primary targets.
Who should we nuke first?
Let's see. How about Las Vegas?
Las Vegas. Great. What next? Seattle!
Yeah!
So have you guys seen War Games? No. Yeah. So is this real? Like in terms of, well, is he playing a game? No, the computer's like your Raspberry Pi. It's like connected to the real world, and then it actually starts launching a real war. Yeah. And everybody's like, ah! Just like I told you, you could do with your Pi. You could launch missiles.
Not in trouble, you sport. Okay, first start.
Okay.
Lehigh, Utah.
Okay, I want to repeat the previous exercise. Okay, so this one is with the 1721. Okay, so how did I know everything about the 172 address given its subnet mask? So first off, I know that this is a class B address because I'm thinking of the charts. Second thing, I can't do anything unless I turn everything into binary. So I turn everything into binary. Now I'm going to use a logical AND to create the third row. So I've created that. Now I'm going to, using that subnet mask, I'm going to look where the ones ran out, drop a line, and that is going to help me know what is my network address. Turn that back into an IP address. What is on the last row? Now I have my network address. I forgot to update that number, so ignore that one. It's hard, there's a lot of ones and zeros on there. So anyway, to create my broadcast address, I presumably would have just changed everything here to 1, and that would give me this address, 255.255. So there's 16, so 8 bits, 2 times is 255.255. So how many possible IP addresses are there? Well, there's 16 slots, so that's 2 to the power of 16, 65,536. And then how many IP addresses are assignable to hosts? Well, I know one of those IP addresses was for the broadcast, and one of them was for the network, so I take away 2 from the possible numbers. That left me with 65,534. So as Captain Picard would say, so easy. All right, I don't see anybody's buying it, but anyway. At least when you work with certain numbers, you'll be able to figure all that out at a glance. So that's nice. Yeah?
So why do you call it a logical AND if you're
I don't know.
It's like a math term. It's
Yeah.
like when you like have two Venn diagrams, it's the logical end is the middle section.
Yeah.
That is what it's supposed to be.
It is a math term. So you can just know what the rule is. You use your so here's another way of describing it. So I was actually so we use the word subnet mask. But what does the word mask mean? The word mask means to hide certain things and reveal other things. That's what our subnet mask does. By putting that list of binary there, it allows us to expose some things and hide some other things. And so hopefully that's what you saw. Yeah?
Also, it's a programming term, like if you have an if statement and you have the double ampersand, it has to be true and true for it to go forward.
Yeah.
So if a 1 is true and a 0 is false, both of them have to be true for it to go forward. So if one of them is false,
So default is 0.
Yep, both of them have to be true for it to be true. Yeah.
will we ever have subnet masks with numbers between the 255 and 0?
Will you ever have subnet masks that are different than 0 or 255? Yes, there is a homework assignment that is currently available. So, as it relates to that, and the way that the homework assignment is going to play out is that at some point before this is due, I will solve the first problem in each of these blocks, and that should help you do the rest of them. And so, for example, this /27 is one that is not going to be a 0 or a 255 when you convert it to binary. Or when you're looking at it that way. So yeah, I like this little cute phrase I put here at the bottom. This question is essentially Mount Doom and Mordor. You can throw the ring in regarding the topic of subnetting when you can answer these questions. You're done once you get through with that. This question block as far as how deep we're going to go with subnetting for this class. Okay. Colby.
In the real world, does that happen a lot that they're not 255?
Yeah. Oh yeah. I mean, it's yeah. That being said, as we play with AWS and in your typical home networks and class networks, you don't typically see it, but it's still really common and easy to do. Okay. So go ahead. So after class today, go ahead and start working on it. I can't remember if I made it due like next Tuesday or next Wednesday. It's one of those days. So just look in Learning Suite. Okay. So there's some minor extra information available about subnet masking here. I think I might leave this to you to read. But one of the things is that for every 8 bits, they always follow a certain pattern. Because of the way we did CIDR notation, we never intermix 1s and 0s. Once we go from 1s to 0s in that second row, it's all 0s after that. So the numbers for a subnet mask, when we convert it into a regular number, is always going to be 0, 128, 192, 224, 240, 248, 252, 254, 255, and it will look like that. So wherever it runs out, if you're looking at bits, it will look like one of these. It's never going to be interspersed. Once you start with the 0s, it never goes back again. So subnet masks, when you do an IP config, they look like IP addresses, but they're not entirely like IP addresses because they can only take on certain values in every slot. So you could play a little game here and see if you can figure out which are valid addresses and which are not valid addresses based on the rules that I just gave you. I'll let you do that on your own, probably throw it on a test. The next slide. Oh, it's so easy. It's crazy easy. And you can just look on the next slide to see what the answers are. So I'll post the slide after class. But let's talk about ARP. Let's talk about ARP, not art. ARP. I said, You can probably guess that I sit up in my office and I crack myself up sometimes. Thinking of nerdy things, I couldn't wait to get to this one. So ARP. So if you're a criminal, you go into a room and you case the joint. You go into a bank and you look for where's all the security cameras, where's the security guards, where's the money, where's the little button to sort of, call for the cops. We do something a little bit similar if you're single. In like wards, singles wards. You case the joint. You figure out where's the girl or the guy that you're interested in. You might compare that to MAC and IP addresses. Like, as week after week goes by, MAC address-wise, you know who they are as an individual. IP address-wise, they kind of move around in the room, but you're pretending like you don't know where they are, but you know where they are. All right. So my analogy is that ARP is a little bit like that. You're keeping track of the MAC and the IP addresses of the other computers that are in the room. See, that was delightful. I love making that stuff up. Okay. So you got a table in your head of who the person is that you're interested in and where they are on any given day, even if you're trying not to. Okay. So let's look at an ARP table. So if I were to go over to, I'll look at this in 3 different places. So first off, I'll start off on my Raspberry Pi, and I can type in so I'll do ARP-A. Okay, so what I see here is not that exciting currently, but it has a table, a cache of information mapping MAC addresses within its network, local area network, to IP addresses. This particular IP address is critical on my network because it represents the router, the way that I get out to the internet from my Raspberry Pi. When I did this the first time yesterday, this is what it looks like. So, which was kind of interesting. So, 1.249.3.249, all kinds of different ones. I'm looking for the one that said Nintendo on it. I'm not seeing it right now, but like some of these say like TVs and our Nest Mini. It seemed like one of them, when I pulled it up the other day, actually had some additional information that showed that it was one of the Nintendo devices in the house. At any rate, over time, my Raspberry Pi had picked up a bunch of MAC addresses in my house and what IP addresses were associated with them. We can do the same thing on our Macs. We're not going to get all the way through this, but I can do ARP/A on my Mac. So in terms of this room right now, I see some MAC addresses and some IP addresses associated with it. So one of the reasons why this exists is because, again, on our local area networks, we only communicate with one another at the physical layer based on MAC addresses and oftentimes that physical connection across a wire. But we refer to each other by our aliases, and the IP address is that alias in a private local area network. If I go to if I go over to my PC, my Windows, okay, I can type in ARP-A, and again, I see a bunch of MAC addresses in its network, as well as the IP addresses associated with that MAC address. Let me reopen PowerShell, and you saw that there was stuff there. So I'm gonna type power. I'm gonna right click on it, and I'm gonna say run as an administrator. And I think I want to do ARP-D*. That means I want to clear out my cache. And then I'll do ARP-A. And now there are less entries that are sitting in there. So there's a different command that I would use for Linux. And we've got about 2 to 3 minutes left. This is pretty cool. I'm going to use Wireshark here to show this off. Unless you want me to save it for next time because you want to follow along. You want me to save it for next time? Yeah. Okay, it's pretty cool. So what I'm gonna do is I'm going to clear my cache on my my Linux machine, and then I'm gonna start a Wireshark capture, and then I'm gonna watch what happens in Wireshark as the ARP table gets renegotiated. And it essentially looks like Marco Polo. I'm gonna see these packets going back and forth across the network that says, who has 192.168.1.1? And then my Google Fiber router is going to respond and says, I, with this MAC address, am 192.168.1.1. So that's what we'll see. It's kind of fun. All right, hopefully you captured enough based on the subnetting material that you can start moving through that homework assignment. You're going to have to practice it in order to really have it settle in, I think. But hopefully you've got enough that you need for this class at this point. If not, we'll back up and regroup. Have a great day, great weekend. That was beautiful. Sorry, Kyle. That was pretty brilliant.
No, thanks.
Oh, you're right.
It was too good opportunity.
And I had explain that to me.
Yeah, because he's asking for that.
I probably will, yeah.
There's a 415 on Tuesday. That's right, yeah.
So, is this a multi-site?
So here's how you solve this one. Okay, you start off by making 2 rows. Turn that into binary, and then turn that into binary. And then you lose C, draw my line. Now this one says, it's gonna build off this previous like problem, and it's gonna say, hey, assume this is a class C network. So that means that
If you guys find a different spot
right now,
might be.
say, so based on that.
Yeah, I just. You can take
And it says,
I feel like before I got married, I would eat that.
Bower jacket,
But now,
like
no,
that down
before I
jacket
got
that
married, I
I
wouldn't eat that, but I was married.
Yeah.
But yeah, tomorrow night.
Yeah, for sure.
so what you can do is,
It's all vulgar.
as you draw this out, 27 digits. Draw a line, everything, turn everything into zeros, and then you're gonna put a new address there. And it might say like 199.255 dot, like 95.128, or it's just, it'll be some number, or 196 or something. That, and it's in one, so that's gonna be weird, because instead of .0 for your network address, suddenly, for this one, your network address is gonna say like 190, yeah, like 192 or something. Whoa, so that's your low end. So everything has a range. So usually our ranges are like, hey, for our 192 address, typically it's like 0 to 255 is our range. But sometimes it can be like 192 to 254.
Right, it's just a weird, it's just a, but it's always gonna be
Yeah.
an upper, yeah. Makes
Yeah.
sense, I'm getting it.
Yeah.
Makes sense, yeah.
And and so that's as hard as it gets. So I feel like I started off with, hey, look at all these easy math ones where it's always 0 and 255. Here we make it a little bit more complicated. We show some examples where it doesn't always start with 0 and it doesn't always end in 255, but it's the same idea.
Okay, follow-up. So, what's the case in which I might have a higher number in the subnetted network on this little guy right there? So, I understand that this would be, 24 would be assigned to the network, and an additional 3 would be assigned for the subnetwork.
Yeah.
And then, and then I do all that with the zeros. And then why would this number be something different right here? Does that question make sense?
Well, when I say subnetwork address,
Oh, it's not, subnetted network, subnetwork address. Oh, okay, sorry. These are asking for the exact same thing. Here and here, okay. I never mind. Okay. Subnetwork address. Okay, yeah, okay, never mind. I get it.
Okay,
now.
okay, good.
I get it now. Thank you.
good, because I almost lost myself, so.
Okay, yeah. No, thank you. I was just
Okay, and I'm gonna hit stop on you.
Wait, go to